Hello, hi everyone. This is Dr. Yuragvendar, Assistant Professor of Chemistry, MVS Government Degree and PG College, Mahabub Nagar, Telangana. In this video, I want to explain about part 5 of amines. Till now, I developed 4 videos on amines chapter, that is part 1, part 2, part 3, part 4. In part 1, I explained about the classification, nomenclature, as well as preparation methods of amines. In part 2, I explained about the physical properties of amines such as boiling points, melting points, hydrogen bonding, basicity, character of amines, and also the use of quaternary ammonium salts as phase transfer catalysts. In part 3, I explained about the some chemical properties of amines such as alkylation, acylation, carbolamine reaction, Isenberg separation, and also about the reaction of amines with nitrous acid. In part 4, I explained the chemical properties of amines, that is an extension to part 3. In part 4, I explained about the electrophilic substitution, reactions of aromatic amines, oxidation of aryl and tertiary amines, diazotization reaction, and diazocoupling reactions. Okay, fine. In this part 5 of amines, I want to go to explain about the synthetic applications of diazonium salts, importance of diazonium salts, replacement of diazonium groups by various groups such as hydroxy group or halogen atom like chlorine. That is, the reaction is generally known as Sandmeyer or Gotterman reaction, or replacement of diazonium group with chlorine, which is generally known as Schumann reaction, replacement of diazonium group with iodine, or replacement by cyano group, and replacement of diazo group with nitro group, and replacement of diazonium group with hydrogen, and also replacement of diazonium group with aryl group. Sorry, it is not AT, it is A, or it is A, or sorry, mistake, AR group, aryl group. Next one is reduction of diazonium salts to aryl hydrogens or hydrogens. Okay, fine. Next, first one is importance of diazonium salts. Why we have to know about the diazonium salts? What is the importance of diazonium salts in organic chemistry? As we discussed in our previous video, that is in part 4 of amines, I explained about the diazotization and coupling reactions of diazonium salts. Due to the diazotization reaction, primary amines, that is mainly the aromatic primary amines, converted into diazonium salts. These diazonium salts have lot of application in synthetic organic chemistry. If you observe the applications of some of the applications of diazonium salts, the first one is they have applications in dye and pigment industry because they produces various dyes. Because by using diazonium salts, or we can convert diazonium salts into various dyes. Dye means a colored pigment or colored compound which can be obtained on treatment of diazonium salt with some other aromatic compounds, which is nothing but we can get them through coupling reaction, as we discussed in our part 4 video. The other application is, it is very useful, that is, these diazonium salts are very useful to synthesize a large variety of organic compounds. Especially we can synthesize or we can prepare a variety of or large variety of aryl derivatives by using diazonium salts. In organic synthetic chemistry, the diazonium salts acts best intermediate or best raw materials in order to prepare various diazonium compounds. Okay, next, here if you observe some examples, it is very difficult to prepare directly iodobenzene. It is generally difficult to prepare iodobenzene, or it is difficult to substitute iodine on iron ring, but we can easily prepare iodobenzenes by using diazonium salts. It is also difficult to replace or to substitute chlorine atom or bromine atom with cyano group in order to get cyanobenzene, but we can achieve it simply by using diazonium salts. It is also difficult to prepare fluorobenzene directly, but we can simply or easily prepare fluorobenzene through treatment of diazonium salts with respective fluorine containing molecule. Okay, next one. It is impossible to prepare some substituted aromatic compound by direct substitution on arene ring, but we can get simply those substituted arenes or aryl derivatives by using diazonium salts as raw material or as starting materials. So we can prepare various compounds or various aryl derivatives by replacing diazonium group of diazonium salts with halogen atoms such as fluorine, chlorine, bromine, iodine, or we can replace them with nitro group, or we can replace the diazo group with hydroxy group, or we can replace with cyano group, or we can also substitute one more arene ring into aryl diazonium salt. Okay, fine. This is about the importance of diazonium salts. That is, diazonium salts have a lot of applications in synthetic organic chemistry. In order to prepare most of the aryl derivatives, we can simply prepare some aromatic compound which are impossible to prepare through direct methods. Okay, fine. Next, so observe some of the replacement reactions of diazonium group. Diazonium group is N2 N2 plus X minus. In the case of aromatic diazonium salts, the general formula is A or N2 plus X minus. But in the case of aliphatic, it is or N2 plus X minus. Aliphatic diazonium salts are, they are unstable one, so it is less to know the applications of aliphatic diazonium salts. Okay, replacement of diazonium group of diazonium salts. The first one is replacement by OH group. How can we replace diazo group with hydroxy group? It is generally aryl diazonium salts or aryl diazonium ions generally obtained on treatment of aromatic amine, that is sorry, aromatic primary amine, here only aromatic primary amine with nitrous acid below 10 degrees centigrade, that is mostly below 5 degrees centigrade, we get corresponding diazonium salts. It is generally known as diazotization reaction, that is conversion of aromatic primary amine into corresponding diazonium salt on treatment with nitrous acid under ice cold conditions, that is below 5 degrees centigrade, generally known as diazotization reaction. It is useful to prepare diazonium salt. If you observe the diazotization reaction, that is, for example, reaction of aniline with nitrous acid below 5 degrees centigrade, we get corresponding diazonium salt, that is phenyl diazonium chloride or benzene diazonium chloride. Here nitrous acid is unstable one, so it is prepared through in situ methods by taking the mixture of nitrate salt and acid. Okay, this is diazotization reaction. Generally here the products which obtained in diazotization reaction, or they are generally stable below 10 degrees centigrade only. Above 10 degrees centigrade they are very unstable and undergo breakage to form different products. So if you raise the temperature of the diazotization reaction above 10 degrees centigrade, the diazonium ions undergo dissociation or undergo reaction with different ions to form different products. So it is one method to prepare phenols from hydrolysis of diazonium salts above 10 degrees centigrade, because below 10 degrees centigrade they are stable one due to resonance in the diazonium ion, so they don't undergo much reaction. So if you raise the temperature of diazonium salt above 10 degrees centigrade, we can convert them into desired products, that is hydrolysis of diazonium salts above 10 degrees centigrade, we get corresponding phenols, that is treatment of diazonium salts with water above 10 degrees centigrade, we get phenols, and also the nitrogen gas is liberated. Here the diazo group removed as N2 gas, we also get HCl byproduct. Okay, this is about replacement of diazo group with hydroxy group, that is conversion of, it is best method to convert aromatic primary amines into corresponding phenols, that is it is used to convert NH2 group into hydroxy group through formation of diazonium salts. Okay, next, replacement of diazo group with halide, that is it may be chlorine or bromine. Generally this reaction is a specific named reaction based on the scientist who find out the reaction. There are two types of named reaction. One is Sandmeyer reaction. Sandmeyer reaction is generally used to substitute or replace the diazo group with halogen atom such as chlorine or bromine. What is Sandmeyer reaction? Sandmeyer reaction is nothing but it is treatment of diazonium salt with cuprous halide in the presence of same hydrogen halide. Then we get corresponding halobenzenes. That is reaction of diazonium salts with cuprous halides in the presence of same hydrogen halide. We get respective halobenzenes, which is generally known as Sandmeyer reaction. Okay, fine. Next, this is example for sorry. This is example for Sandmeyer reaction. Here, in Sandmeyer reaction, it is bromobenzene. Sorry, sorry, 1 minute. Here, on treatment of diazonium salt with cuprous chloride in the presence of same hydrogen halide, that is hydrogen chloride, then the diazo group converted into or replaced by chlorine atom, so we get corresponding chlorobenzene. If you treat the diazonium salt, that is phenyl diazonium chloride, with cuprous bromide in the presence of hydrogen bromide, then we get corresponding bromobenzene. This is Sandmeyer reaction, that is conversion of diazonium salt into corresponding halobenzene on treatment with cuprous halide in the presence of same hydrogen halide. Here the halide is generally chloride or bromide, but not iodide or fluoride. That is, it is useful to prepare chlorobenzene or bromobenzene from diazonium salts. Okay, next, Gattermann reaction. Gattermann reaction is it is just a modified reaction of Sandmeyer reaction. In the case of Sandmeyer reaction, diazonium salt treated with cuprous halide in the presence of same hydrogen halide. But in the case of Gattermann reaction, diazonium salt is treated with hydrogen halide in the presence of copper powder. Instead of taking cuprous halide, we have to take copper powder in Gattermann reaction. In the case of Sandmeyer, it is hydrogen halide and cuprous halide. But in the case of Gattermann reaction, it is hydrogen halide in the presence of copper powder. Then we get corresponding halobenzene, that is maybe chlorobenzene or maybe bromobenzene. That is treatment of diazonium salt with hydrogen chloride in the presence of copper powder, we get chlorobenzene. But treatment of diazonium salt with hydrogen bromide in the presence of copper powder, we get corresponding bromobenzene. Okay, fine. Next, one is a replacement of diazo group with cyanide group, CN group. We can replace diazo group with cyano group on treatment of diazonium salt with cuprous cyanide in the presence of hydrogen cyanide, or in many cases it is alkali cyanide, that is potassium cyanide or sodium cyanide. That is treatment of diazonium salt with cuprous cyanide in the presence of alkali cyanide, or some cases it may be hydrogen cyanide, we get corresponding cyanobenzene or cyanoherins. Generally, the this reaction is a special type of Sandmeyer reaction because in Sandmeyer reaction, diazonium salts treated with cuprous halide in the presence of hydrogen halide, same hydrogen halide. But here the reaction is, instead of taking cuprous halide, we have to take cuprous cyanide. Instead of taking hydrogen halide, we have to take hydrogen cyanide or alkali cyanide. So it is a special type of Sandmeyer reaction. So we get corresponding cyanoarenes from phenyl diazonium salts or benzene diazonium salts. We can get cyanobenzene. Okay, next, replacement of diazonium group with nitro group. It is done by treating diazonium fluoroborate, aryl diazonium fluoroborate with sodium nitrite, not nitrate. It is nitrate. Treatment of aryl diazonium fluoroborate with sodium nitrite in the presence of copper powder. We get corresponding nitro derivative. For example, treatment of benzene diazonium fluoroborate with sodium nitrate in the presence of copper, we get nitrobenzene. Here nitrogen gas is liberated as byproduct. In all the replacement reaction, liberation of nitrogen gas generally takes place. Here diazonium fluoroborates generally obtained on treatment of diazonium salts with hydrofluoroboric acid. Okay, fine. Next, the next one is on replacement of diazonium group or diazo group with hydrogen atom. It is best method to convert amines into arines. That is, replacement of diazo group is used to remove an amino group from arine ring. It can be achieved by treating diazonium salt with hypophosphorus acid, hypophosphorus acid, or with sodium stannate. Treatment of diazonium salts with hypophosphorus acid or sodium stannate, we get corresponding arine. That is, the amino group converted into H, or the amine aromatic primary amine converted into corresponding arine by using this method. In order to achieve this, we have to treat aromatic primary amine with nitrous acid below 5 degrees centigrade. Then we get corresponding diazonium salt. This diazonium salt on treatment with hypophosphorus acid. The formula of hypophosphorus acid is H3PO2. Treatment with hypophosphorus acid, we get corresponding arine. Here in this specific example, phenyl diazonium chloride or benzene diazonium chloride on treatment with hypophosphorus acid, we get benzene. Okay, next, replacement of diazo group or diazonium group with iodine. It is difficult to substitute iodine on iron ring directly, but it is easily achieved through diazonium salts. So, in the first step, aromatic primary amines converted into corresponding diazonium salts. These diazonium salts next treated with alkali iodide, that is potassium iodide, mainly with potassium iodide. Then we get corresponding iodoerins. If you take specific example here, diazonium phenyl diazonium chloride or benzene diazonium chloride on treatment with potassium iodide, we get corresponding iodobenzene. So it is best method to prepare iodobenzenes or to substitute NH2 group with iodo atom. That is, in this, according to this method, we can convert aromatic primary amine into iodoerin. Okay, fine. Next, next one, replacement of diazo group with fluorine. It is a specific named reaction. The named reaction is Schumann reaction. Schumann reaction. Replacement of diazonium group with fluorine, generally known as a Schumann reaction. Here it can be achieved through treatment of diazonium salt with hydrofluoroboric acid. Hydrofluoroboric acid, we get corresponding diazonium fluoroborates as intermediate. We get fluoroborates. This diazonium fluoroborates on heating undergo dissociation to form corresponding fluoroerins. In this example, benzene diazonium chloride, or it is also known as phenyl diazonium chloride, on treatment with HBF4, that is hydrofluoroboric acid, we get benzene diazonium fluoroborate. This benzene diazonium fluoroborate on heating converted into fluorobenzene by losing boron trifluoride and nitrogen gas. Okay, this is about Schumann reaction, that is conversion of diazonium salt into fluorobenzene. Okay, next one, replacement of diazo group with aryl group, that is with AR group. It is achieved by treatment of diazonium salt with iron in the presence of dilute basic solution, that is, it may be dilute sodium hydroxide or potassium hydroxide, that is mainly in the presence of alkali solution, we get corresponding iron. This is also a special type of named reaction. This is generally known as Gomberg-Bachmann reaction. Gomberg-Bachmann reaction is nothing but conversion of diazonium salts into arins, or replacement of diazo group with arin ring on treatment of diazonium salt with dilute alkali solution, generally known as Gomberg-Bachmann reaction. That is, here the diazo group is replaced by one more aryl group. So in this Gomberg-Bachmann reaction, we get biphenyl derivatives or by aryl derivatives. If you treat benzene diazonium chloride with benzene, the presence of base, that is sodium hydroxide, we get biphenyl. If you treat orthochloroaniline with nitrous acid, we get orthochloro benzene diazonium salt. This orthochloro benzene diazonium chloride salt on reaction with benzene, we get orthochloro biphenyl. It is substitution of aryl group. That is, it is example per Gomberg-Bachmann reaction. Okay, fine. Next, reduction of diazonium salts to form aryl hydrogens. That is conversion of diazonium salts into aryl hydrogens. Here hydrogen is, the formula of hydrogen is, it is N2H4. If you replace one of the hydrogens of hydrogen with aryl group, then we get corresponding aryl hydrogen with a general formula ARNH2. So here diazonium salts are best starting material to convert them into corresponding aryl hydrogens. It can be achieved by treating diazonium salts with sodium sulfite, not sulfate, sodium sulfite. The formula of sodium sulfite is Na2SO3. Formula of sodium sulfate is Na2SO4. SO4 is sulfate, SO3 is sulfide. So, treatment of aryl diazonium salt with sodium sulfite or with stannous chloride, SnCl2, followed by acidification with hydrogen chloride or hydrochloric acid. We get corresponding aryl hydrogens. Here in this reaction, the hydrochloride derivative salts generally crystallizes on cooling. Here in this reaction we get hydrogenium salts. On cooling, the hydrogenium salts converted into crystals. These crystals on treatment with base, that is sodium hydroxide, converted into pre-hydrogen derivatives. If you observe the example here, aniline undergo reaction with nitrous acid, that is diazotization of aniline produces benzene diazonium chloride. This benzene diazonium salt on treatment with sodium sulfite Na2SO3 or with stannous chloride SnCl2 converted into aryl hydrogenium salt on treatment with hydrochloric acid. This aryl hydrogenium salts further converted into free aryl hydrogens on treating with base, that is we get this aryl hydrogen, that is phenyl hydrogen. Okay, so this is a best method to convert aromatic amines into corresponding aryl hydrogens through formation of aryl diazonium salts as intermediate. Okay, fine. Next, if you observe the summary of the all the replacement reactions or the importance of diazonium salts, how can we get various hydryl derivatives or various compounds from diazonium salts? As we discussed in the previous slides, hydryl diazonium salts have a lot of applications in synthetic organic chemistry. So, if you summarize all the reactions which we have discussed in the last slides, we get this slide. Okay, if you observe this summary, this is the central molecule to prepare or the starting molecule to prepare various compounds. This is diazonium salt or diazonium ion. If you treat the diazonium salt or the if you hydrolyze the diazonium salt at above 10 degrees centigrade, here heat is generally above 10 degrees centigrade, greater than 10 degrees centigrade, 10 degrees centigrade, above 10 degrees centigrade, we get corresponding phenols. Next one, if you treat the diazonium salt with cuprous cyanide in the presence of hydrogen cyanide or alkali cyanide, we get corresponding cyanoaryne, cyano derivative. It is a specific case of Sandmeyer reaction. If you treat diazonium salt with hydrofluoroboric acid HBF4 followed by heating, we get corresponding fluorobenzene. It is a Schumann reaction, that is conversion of diazonium salt into fluorobenzene on treatment with hydrofluoroboric acid followed by heating, known as Schumann reaction. If you treat diazonium salt with hypophosphorus acid H3PO2 hypophosphorus acid or with sodium stannate, we get corresponding rin. That is, diazo group is replaced by H. We get corresponding rin. Okay. If you treat diazonium salt with cuprous halide, that is cuprous bromide, it is generally in the presence of HBr, in the presence of HBr, then we get corresponding bromobenzene. It is Sandmeyer reaction. If you treat phenyl diazonium salts or aryl diazonium salts with cuprous chloride in the presence of same hydrogen halide, that is hydrogen chloride, hydrogen chloride, we get corresponding chlorobenzene. If you treat diazonium salt with potassium iodide directly, we get iodobenzene. If you treat the diazonium salts with some other aromatic compounds, it may be phenols or amines, we get coupling products. I discussed about the coupling reactions of diazonium salts in the fourth, that is part 4 of amines video. Here coupling reaction is nothing but coupling of diazonium salt with other aromatic compounds, generally known as azo coupling. Here the diazo group couples the two bulky arene rings, so it is known as azo coupling reaction. Generally coupling reaction takes place in between the diazonium ion and phenol or amines in the presence of base and acid media respectively. That is treatment of diazonium salt with phenol. Generally it is in the presence of base media. Base is, it may be sodium hydroxide or potassium hydroxide, because here in the presence of base the less activating phenol molecules converted into more activated phenoxide ion, which enable the post coupling in between the diazonium ion and phenoxide ion to produce corresponding coupling product. The all the coupling products are generally have a specific color, so we get colored compounds. These colored compounds are generally known as dyes. So the diazonium salts have lot of applications in pigment industry as well as in dye industry, and also in cloth industry in order to color the cloths. If you treat the diazonium salt with amine in the presence of weak acid, we get corresponding diazo products or coupling products, which also a colored compounds. This is all about the synthetic applications or conversions of diazonium salts into various aryl derivatives. Okay, fine. Next. Okay, thank you very much for watching this video. One and all, thank you very much for your patience. Okay, bye.